the and but today we'll be listening from him about the lab scanner. Lab scanner, he'll be showing us how the model has been poured. Those models can be scanned. So with this, I invite you, Dr. Bhaskar, to proceed, please.
My screen is visible?
Yes.
Just give me 2 minutes, ma'am, please. The layout of my screen or the whatever it is fine?
Yes.
Okay. Okay, so good evening to everyone.
Is it on slideshow mode?
I think not.
I don't think it is on slideshow because we can see all your slides on the side panel.
Yes, why it is not happening?
So you need to put it on slideshow mode. Yes.
Okay. Yeah. So now it is fine.
Yes.
Okay. So good evening to all of you. This is my lecture before mostly the doctors here in this meeting room. Okay. And basically I am an engineer. Okay. So definitely you will get some flavor of engineering point of view. That's why I have written one more word here. It is a lab scanner, a reverse engineering. Okay. So basically, the part we have covered till now previous days, various type of imaging techniques, intraocular scanner, some of the little bit extraocular scanners. So mostly things are oriented towards the dental area. Okay. So, but I am looking this one as this is all kind of scanning devices, as it is a kind of reverse engineering. If we will see this one, because uh, that I would like to throw some light on reverse engineering, that if any object is existing, okay, then if you take the geometry by scanning or by any means, and we remodel it for our own purposes. Okay. So this is a kind of, so this lab scanner or any kind of scanning devices used even in CT scan or MRI or anything, all are kind of a part of some reverse engineering. Okay. Because we take the data from the object, and here our object is the human organs, or it may human organs, or it is a dental especially. So we take the data from those things. Okay, so we have some the geometrical information in terms of our the data form, that is a very soft form of the data. Okay. So we take this data and we use this data for our own purposes. So it is a kind of a reverse engineering. Whole process is basically reverse engineering, because this is also a hospital or any medical profession. It is a service to the some customers, and customers is our the right now it is a patients. So we try to satisfy our patients by treating them well in terms of quality, in terms of low cost, everything is there. Okay, so basically reverse engineering also we call it is a backward engineering or back engineering process. So we start from the object and we remodel it through our scanning devices and create our own soft model. Okay, in place of having directly going to utilizing any software for creating geometrical model. So advantage is that it is a basically the complete customized things, because the, and if we talk about in terms of customization, so basically customization is because each and every our patient is a specific, they have their own features, their own every design and geometry, everything is a different. So if we talk about a customized industry, so this is basically, or then we because it relates to the 3D printing that is known for purely customization. It means each and every product is for the specific person. Okay, so this medical industry is fully covers that customization part. Okay, so we can see here the process that we if we want to take the scan of any object. Okay, whether it is a any the organ or any object in general purposes for. So we first we prepare the object. It means that many times our scanners are not doesn't scan suppose black portion, black colors. Okay, so some kind of preparation we need. So then we start scanning. Then after scanning we get the some data, and we import through the softwares in some particular file format, and we create a geometrical model. Then geometrical model, this is surface generation. Basically it is a geometrical model. Surface means many times we are not interested what is inside. Okay, we are covering the outer geometry of the teeth or any plant or anything. Okay, so this is outer geometry. Surface generation means basically from outward side of, not from the inner side of point of view. Okay, so complete if your model is ready, then we go for manufacturing of the our in case of specific it is an implant or any kind of prosthetic, that is even for legs or for any hand or any prosthetic. Okay, we go for manufacturing. So it can be through our your any kind of conventional process, casting based process, or any advanced digital manufacturing in terms of a CNC machines. Okay, or any 3D printing is also some digital manufacturing. So we create a prototype, then we do some checking of the model, and we validate for our own purposes. So finally you have directly a physical model. Okay, so it is very useful because we prepare the documentation we do. We prepare the document, what is the size, what is the drawing, everything is there. Making copies, you can make a more product, like a when we scan so many patients. So we suppose we want to have we want to do some commercialization. So we classify the age, a range of patients, and we think that this kind of 4 segments or 5 segment product is required on the basis of your area or your uh, maybe some regional issues are there. So some kind of you have some so you create you make some copies. Okay, so that you can have it directly, your implant or things are available to you directly to use, not by going, because not going by making product for each and every person. Okay, so it a little bit, definitely it is not it is little bit some generic. So the cost will be low. So we can create some educational tools like our dentist dental surgeons. We will create some different kind of models for educating them, for giving even for surgical purposes. Okay, so this is in view of some kind of object that we object scan file, and this is a similar kind of up to the fabrication. So this is workflow. So by using this reverse engineering word, I am it is only due to that our application part is our dental area. Okay, so so we can replace either it is a dental or it is any kind of object that we want to create its drawing in soft form, and then we play with the drawing for our own purposes. Okay, so intention may be different many times, but the things are almost the same. So as we see that for these purposes, we have some non-contact 3D scanners, okay, and context-based 3D scanners. So context-based 3D scanners, like this coordinate measuring machine, this is for engineering purposes. Otherwise, you have you have a scanners in your dental area. Of scanning, and it is directly in touch with the object. And rest of the most of the you are interested for non-contact devices, non-contact 3D scanners. Okay, so these rest of the devices used for reverse engineering or making model CT scan MRI. So we are these things are out of scope for present talk. Okay, so we are more concerned towards the scanners. Okay, so so here a little bit more classified way it is given, a non-contact type of scanners. It is a laser scanners, optical scanners, and blue light scanners. So as in terms of cost, we try to have more options, and definitely all are having some advantages, some disadvantages, because suppose we want to scan whole building, suppose we want to have some other small objects. So according to the and nature of the geometry is also important for scanning the for selecting the scanners. So, but we will not go into the detail that how this laser scanners works and optical scanners. Okay, so but we have some options, and it depends upon the company or the manufacturer using which kind of technologies. So these are some categories of this 3D scanners, like a measuring arm 3D scanners. I have this is contact type. It touches the probe. There is a probe which touches the object and gets the coordinates. So definitely this had some kind of limitations, because there is a this probe is not good in comparison to the lasers or any kind of light-based devices.
Yeah.
So, yes,
Dr. Jiten, if you can show us the scanners, it would be good, because the workflow would be covered by Dr. Ashutosh after your lecture. So then
okay.
he will be able to show us how the workflow is.
So, but right now I am not going to show the kind directly the demonstration. Uh, so, but I have taken the some pictures. Okay, so from that, with the help of those things, I will explain the things. Okay. So, uh, these are the, I think you will be more friendly to these kind of scanners. So these are the some features of given for this white light and structured light, and this has been taught, I think, in previous lectures. Some of, I think it in the first lectures covered some advantages, disadvantages of kind of lectures. Okay. So the other important aspects of this kind of lab scanners are the various, in addition to the some your medical area. So other areas also covered using these lab scanners. It is a kind of handy scanners, or some big scanners are also. So we can create a model of any kind of specific things, like we want to store it skeletons or some kind of other the very old things that we are having. So even for medical purposes also we take these things. Any and so there is an Artec 3D scanning camera is there. This company is very renowned company, and they sell so many kind of scanners. Okay, so these are the some other examples of scanning ears that ma'am, you are also working in this area, uh, and scanning of hands, and the facials scanning. Okay, and like a foot scanning is there. Okay. So so the finally that already shown here that you take the those things and for create the any artificial ear for implanting purposes. Okay, so that this is a ear that we created using that syringe or the silicon material is used, and this is the syringe that we print using these your files that we have scanned of any particular patient. So this is a little bit more, and there are other applications that in general nature that you support, but this doesn't require the lab scanner or the so all are depending on other devices. So lab scanner that is covers also not only for dental area. So any we can scan the leg, foot, or for making any orthopedic cast for other treatment for orthopedic surgeons, so for treating or rehabilitation purposes for foot or for any grasping things. Okay, for so we can create all those things. Okay, so these are the other examples in this area that mm, we create this cast, okay, or a 3D printed cast by scanning the hand of a particular patient, and then we create a specific design using 3D printer, and that is more useful for any rehabilitation, even healing purposes, where the swelling is more there. So, and we optimize the design of this cast, 3D printed cast, in terms of weight, or in terms of also the color, or because people are not interested to wear, or not they don't like to go into the parties if they are having some kind of fracture or having a plasters on their hands. So we design things. So this is also a very good example of lab scanner for, because CT scan and MRI is not required in these cases. We take the approximate geometry of the particular patient, so we can easily
So
scan it.
I
And
think this type
yes,
of scanning can already be done using maybe a face scanner or
yes.
scanner.
Yes,
So
that
both
is.
of them. When do we particularly want to have a lab scanner? Means if we have scanned with the available scanners,
Yes,
then
yes.
why do we need to have a lab scanner to scan?
So, no, madam, please specify. I think
Yeah, wanted all to understand that if we can scan a thing using an intraoral scanner or an extraoral scanner, fine. But suppose we have already have a model of that, and we don't have the patient now, that so that we can't scan the patient directly. Instead, we have that model and we want to scan the model. That is the time when we actually require lab scanner to
yes,
scan
yes.
that model.
Yes, ma'am. So both the things, if the patient is there, so you can utilize lab scanner for directly scanning. Basically, lab scanner means it is scanning the outer areas. Basically, the theme is that. So whether you directly scanning, like if because that time is patient is there, you are scanning their faces because patient is there. Other, if like in, it is a little bit different in dental area, that because conventionally we are solving problems using a fixed kind of process, where this is making some little bit difference in terms of some if we relatively, if we think about the intraoral scanners. Okay, that time we directly take the data of the data from the patient, but because due to the cost, because intraocular scanning and things are costly, so and it is also the without scanning, that was the past practice by taking the impressions and making the things. Maybe some expert person may can directly see the design and can make a replica without those things. So the basic thing is you are scanning something from the outer portions. That is the main thing. So directly you can scan hand or faces, or you can scan any model like a dental. When you take the impression prepared from any this material, and it is in your hand, because every dentist is not going to have this kind of a scanning devices. So this is a kind of a way out, that you take the impressions and it goes to the laboratory, and you scan it and prepare the things for those specific. So lab scanner, from the dental point of view, we for directly calling it from the this name, that we are taking the we are scanning the directly a already prepared a model of physical object, physical model, that is using POP, some plaster or some other things. Okay, so from that point of view, I am taking the some similarity. Okay, so these are the other examples. So I think. So I want to show a little bit data in terms of I talk. Then I will show you some videos. So a couple of minutes, we can see the market of this the digital market, digital manufacturing, or because it is related to the scanning. That whole thing is that is around. Well, in the business, we can see that is growing very fast way. So you can see 2019 figure, and then finally you can see the 2024 that the 34.8 billion. The growth is 23.5%. Okay, so these are the other data of other countries you can see. So in India, we can say in digitization, maybe we are 3 to 5% here. Okay, so in this whole industry, because dental industry is also a very this is a very big market, and so definitely the impact of all, those things that is happening around us in terms of digitization, it is coming to us, finally reach to our this dental industry also. So it is going very fast. So in healthcare, it is we can say specifically for healthcare. It was 713 billion in 16, and finally it is going to be the in terms of billions 3.5 in 2025, and so this is a very so a little bit. This is a lab scanner. That is we are having this lab scanner. This is a handheld lab scanner that we use for in our laboratory. So this is infrared light based 3D scanner, and its make is 3D system. Okay, it is 2 times written. Its make is 3D system, and it is a low cost scanner for our laboratory purposes, for demonstration purposes.
Yes. So it may scan, but the accuracy may not be good
yes,
enough
yes,
for
yes, yes,
dental purposes, I suppose.
yes, yes, right. It is not fulfill the need of the dental, but it is giving you students basically for, because it is a low cost around 40,000. So it will give you some idea to the student that what is 3D scanning, how we scan it, and what are the different steps in scanning. Okay, so this we are utilizing, and even for scanning for making selfies, 3D selfies, it helps a lot. It can scan, but it is little bit because it is used by manual process, by taking the camera in your hand and then scanning it, so there is some disturbances. But here you can see this range is a 0.2 meter to 1.6 meter, and scanning volume is, it is a big size scanning volume, 2 into 2 2 meters by 2 into 2. Okay, so it is a 2 meter is big size, and we can see we scanned this cattle here. So it is a oh, so this is a cattle we scanned, and this is a model, and this is STL file. Okay, so we prepared this, and finally we printed this one. So this is a complete process of we are scanning a object and then we are doing the things and finally getting a 3D printed. Okay, so this is a kind of a proper explaining the methodology of how our lab scanners can be utilized for making a replica. So all the file formats generally we take. So in there is some facility that we can select we are going to scan object or any head or any complete body of some person. So this kind of selection, there are three options are given there. Okay, and then after scanning, we some do some post processing, like a cropping of the model undesired scan points to be, and this is a solidify and hollow base because
Dr. Bhaskar, please unmute yourself. There was a lot of disturbance, so I muted everyone.
Okay.
Yeah,
So
please.
basically, this is the important feature of any lab scanner, dental or our for engineering purpose, because we scan outer area. So basically, it takes the data of outer surfaces. It is not going to inside what is there.
Yeah, basically
Okay.
it is a surface scanner. So
Yes, yes,
the lab scanner maybe, I think some of the lab scanners are contacting the surface to know where the surface is and then
yes.
scanning.
Yes, but it is a non-contact type, and so we can solidify this one for when we go for suppose tooth or implant. When we go for manufacturing, so because actual object is not hollow, so we solidify it. Sometimes we create a hollow portion, like you can say crown is there, or so for that purposes, you can do like this. So. So these things, I think, because my slides are not completely 100% arranged as per your according to the dental needs.
Yeah, we would love to see the video you have.
Yes.
Then we'll have to proceed to Dr. Ashutosh to take us to the CAD CAM workflow. So
Okay.
we can have your videos, then we'll move on to Dr. Ashutosh then.
So,
yeah, so this is the lab scanner we were talking about.
yes. So after taking the impression, we are putting here, and then from the top side, the scanning lights or lasers comes over it. So these the platform that we are having, or in any scanner, lab scanner. So basically, we want to scan each and every corner of the impression. Okay, so by this way, the platform should be some rotational. So it can rotate, it can orient itself according to the, so that the each and every corner should be projected towards the light. And the or any scanning technology, that is laser or any kind of so we can have a data of each and every corner from there. And then little bit here the intraocular scanners and this kind of lab scanner. So because in case of impression you directly take by using some material, so the beauty of that is that it goes to each and every corner of the your teeth or any cavity is there. So we take those things and scan here. So little bit we can have some more details. And suppose if we are not, if in case of your intraoral scanner, if we are scanning something and not properly reaching to the each and every corner, so maybe the chance that you can skip some of the data. So, but there are so many research paper which says that directly conclude that the intraoral scanners are better one, and they have in terms of a better the getting the each and every details. So these are the Dr. Sumit has given some of the photograph from the laboratory directly. So I am not much expert in this getting all these things. Okay, so I think one video, I think one more video, I think I have, right? So I think it should skip. It is they are using intraoral, or it is useful. Uh, so we can see that how we are taking impressions, or some engineers already joined this meeting, so they can see that. Uh,
How the dental impressions are
yes,
conventionally taken.
are taken. Yes,
And the use of scanners has actually
after
skipped that,
this.
skipped.
Okay.
So
Yes.
there's no need to take impressions like this. And many times these take impression taking like this, the patient is not very comfortable with these material going in
So
the mouth.
we can see that how much it is difficult, or how by using these materials in the mouth. So how everybody feels.
Yeah.
So
Dr.
we
Ashutosh, are you there?
Hi,
yes, so
ma'am.
my part is all
Yeah.
over. So
Yeah.
whenever Dr. Ashutosh can start.
Yeah. Dr. Ashutosh, we really would love to hear from you. Once we have scanned the file, what next? How should we be using them for designing our crowns or bridges or,
Sure, ma'am. Okay, so
yeah,
first I
please.
would like to thank sir. Thank you so much, sir, for your brief. Okay, so I would like to continue from here, from the sir has left. Okay, so just I'll tell the brief, then I'll show you the workflow, how we design for the dental purpose for a single unit crown. Okay, but I just wanted to tell you the brief is, see, we have two options actually. One is an intraoral and second is a lab scanner, as sir said. So I think yesterday we have covered up the intraoral scanner. Now today we'll be covering up the lab scanner. So for dental purpose, as sir said, we have a different type of options. We have the first is a pitch, or I would rather say a tactile scanner, where we used to do the tactile scanning. The pin actually travels from one point to another to capture the data, but that was very old model. Then we come up with the laser, but laser also still cannot pass, and angulated cannot go there, so that was a drawback. Then we all have come up to white light, but what happens is the normal light and the white light is same, so we can, the scanner will not able to differentiate what he is scanning. Now the latest advancement, as we have seen the video for the lab scanner by 3Shape, the blue light is the advanced light, so that that will differentiate from the normal scanner as the the white light. So that's a new advancement. Then a lab scanner or an intraoral scanner, they both scan, but yes, we say intraoral scanners are more accurate as compared to the lab scanner, because intraoral scanners, you're directly scanning to a patient mouth. Whatever the issues, problems, whatever the preparation you have done, we actually able to scan it directly on the patient mouth. Whereas for the lab scanner, we have to take the conventional impression from the putty or alginate or whatever you prefer with the light body wash. But still there are the errors. We have a gagging, we have a dragging options, we have an pores are there, and then we have to pour it on the model. So this is two way we are increasing the inaccuracies on the model. And then the lab scanner, with whatever the technology we have on the lab scanner, we cover up those things. The lab scanner will capture the surface, outer surface actually of the model. Then we get an actually model, digital model. So from there, I would like to start. Okay, so I would just like to share my screen. Okay, I hope everybody can see my screen.
Yes, we can see your screen.
Sure, ma'am.
We can see the scanned intraoral.
Right.
Yes.
So today I'll be showing you that how we do it. Okay. So yesterday we have seen that we scan from the digital, I mean the intraoral scan or a lab scan. So as soon as we scan the digital scan with the intraoral scanner, okay. So the scans look like something like this. Okay. So here we have a preparation on 2.6. So 2.6 is a case which we have to design. Okay. The benefit of having an intraoral scanner is this, that you get exactly the color, shades, everything which is there on the patient mode. Discolorations or not. We can design according to the discolorations and everything. Right. So this is the benefit we have with the intraoral scanner. Right. Second, if we go with the lab scanner, we get something like this. Okay. So the color, if we have a color scanner, the intraoral scan would be looking like this way. Whereas if we scan with the model scanner, we get scan something like this way. These are all imported as sir has informed us. It's all imported in OBGA, STL, DCM, PLY, whatever the format you want, it get imported in that format. So I'll start up with the cover. Okay, as soon as we import the file in the software, or there are the multiple scannings or an option where the scans file directly comes to the design software. Okay, so here right now the workflow is on the design software. So as soon as we come on the design software, the first step we need to follow is to make the occlusion level. Okay, so we have to make the occlusion level of the model or the scans depends on the case to case, right? So here we have a case for 2.6. We'll try to make as the occlusal plane. Okay, we all do the glass plate relation, right? But there are the conditions. For example, if we see the curve of P is not actually what it should be, right? So what we do is we try to make as accurate to the curve of speed. So we'll try to compare here and we'll drag our occlusal plane according to the contacting of the premolars, right? We make a setup here. And you can see the template, it's following the central incisor, the lateral incisors, canine, premolars, and the molars, right? So we have to make this setup. Okay, if somebody has an articulator and the person is scanned the model scanner with the articulator, then we don't have to follow this. But if the person has scanned with the intraoral, yes, we have to follow with this. Then the workflow comes at trimming part. Okay, see, now we know that we are working on the first quadrant itself. To save our cost and time, what we do is we trim the model. Or else we can just continue with the same thing if we want complete arch for the reference. We have an option in the software, which I'll show you later on. We can exactly copy the design from the adjacent side, right? So we have a benefit in the software. Then the next step, same thing, we can do it with a lower scan. If we want to trim it, everything, you can see, I mean, if I want to trim anything, I can do with the lower scan also. Then we have something called a sculpt in the software. Now sculpt happens is, see, if it's an intraoral scan, yes, we know it's an exactly scan taken by the intraoral scanner. But what if it's a scan taken by the lab scanner? As I said, we have to make the impression. Impression need to be poured, and poured need to be scanned. Now, if something is there on the impression, for example, I take it as a dragging, or I take it as a, bubbles. Okay, air bubbles are there. Then the model has also the same, the air bubbles. What we do is sometimes we scrape it or sometimes we don't. So sculpt option we have a plus, minus, and reduce option. We can add up. If you can appreciate this, I'll just zoom it. We can add up the areas. Okay, I'll just change the color and that will be more appreciated. See, we can add up the area, we can smooth up the area, we can reduce the area. And how we'll get to know that what all values we are doing, we have in values here. The how much the depth we are increasing and how much the radius of my covers are. Okay, so this is the benefit of having. We don't have to scrape manually and do it. We can just do it directly on the digital scans. Same thing we have to follow with the lower also. Okay, but we don't suggest anybody to do this. We prefer you better do it on the model or ask the dentist to do it so that they will be knowing better. Then the next step is making the margin. Okay, see, software, it's an artificial intelligence. Software will automatically capture the margin line. Okay, so if we take it as a color scan, see color scan, it's not properly showing us. What we'll do is we'll put up the model scan. We have an option for the color scan to turn up as a model scan. Okay, now how will we do the margin line? See, right now it is all red and it is incorrect margin line. So we have to make the proper margin line so that our crown fits properly, right? So we have some tools here. We can do it from the occlusal. We can do it from the second tool shows. We can do it from the margin line. Third tool is for draw manually. So we always do as well. So first of all, we have to delete the old, which is automatically detected by the software, and we do the manual designing. Okay, so we have to go now. It's all dentist actually. It's all on us that which margin line we take. Sometimes we take an outer margin line. Sometimes we take an inner margin line, and sometimes we get confused. For this case, for example, if I'm confused on where I want, I'll just rotate my scan and check that which is the perfect margin for me. So I can just take it. If I want to have an outer margin line, I'll take the outer surface. But if I want an inner margin line, I take the inner surface. So I'll consider it as inner margin line. So I'll just draw the margin.
So Dr. Ashutosh, once the scan is taken, what software do you suggest should be used to design the crowning
Okay.
on a single?
So ma'am, we have different type of software now available in India. Okay, as sir has shown us, that was the first software which comes from the UP3D. That was a UP3 software, CAD software. Then we have a 3-shape dental system software for designing of crown, bridge, inlets, onlays, veneers, and all. The third software we have, that is for the ExoCAD. ExoCAD is also a good company which designed the software. You can use it. And then we have a different software from Dental Wings also. But they have something as an ExoCAD. So we have majorly, if I talk about, we have two major software. First is dental system, that is by 3-shape, and then second is an ExoCAD to design the prosthetic software.
So if one has a 3D shape software, there's no need to have a CAD software, or is it still needed to have a CAD software?
Okay, ma'am, if the person has intraoral scanner, then it's on the dentist, ma'am. Now, if they want to design it by themselves or they want the lab to be designed for themselves. Okay, so if the dentist want to design, he should have the CAD software. Now, it's his wish actually, if they want to go with the 3-shape with the widest range of application, or they want to go with an ExoCAD with the widest range of applications. Each software has its own limitations. Each software has its own indications also. But yes, it's on the dentist end. Whereas the lab people, they buy the lab scanner along with the software so that they can design also, because their role is not only the scanning. Their role is designing also. So they have to look for the software. So they buy the scanner along with the software, which helps them what they want to design. There are labs, they design only crown and bridge. But there are labs, they design the implant workflow as well. There are the labs, they design cast partial dentures also. So it's all depends the lab workflow which they want, and they design the cases also accordingly. Okay, ma'am?
Yes.
Okay, so we'll continue with this.
Yes,
so we'll be marking the margin line of each model. So right now I'm showing you the one tooth. If it's a full mouth case, we have to do individually for all the cases. Right now we are doing on the 2.6. Right now, just for an information, I am using the dental system software. I have a 3-shape dental system software to use for design. Okay, so we'll continue with the margin line. So we'll design the margin. We'll try to take a little extra margin line because we can trim the crown rather than shorter the crown. So we should make a little bit high points or a higher margin line so that we can just do it a trimming.
Shikha wants to look at maxillofacial designing. Yes, Shikha will be talking about maxillofacial designing as well. But to start with dental designing, then we'll proceed to maxillofacial designing. Is that okay?
Sure. So we'll mark the margin line. Okay, the second step now, the A notation. See, the software doesn't know that you're using an, which tooth. It's a 2.6, 2.7. I mean, software doesn't know it. So you have to mark the A notation. Sometimes the software automatically takes, sometimes you have to do the mark. Then the third and the important thing, which is very important while making a crown, that is the insertion direction. Okay. So insertion direction, what we follow is according to the preparation and the occlusal surface. We have to look from the insertion point, from the occlusal surface, where we can able to see all the margins. Right now, we can see that the red part, can we all appreciate the red part? Red part is the undercut area. Okay. If it's an undercut area, either the crown will not fit from there, or if it's fit also, you have a space there, which can be lead to the micro leakage. So we have to see it always from the occlusal surface where we can appreciate all the margins, right? As soon as we come on this view, I'll zoom it off for everybody. As soon as we come on this view, we have an option here to set. Okay, we have to set from that view. Okay, now we can see all the conduct cuts are there on the wall rather than on the margins, right? Or second option is, if we can appreciate here and we know the patient can come back, we can immediately inform our dentist or the lab person that yes, the dentist need to trim it from the occlusal surface of the distal side of the tooth so that the insertion direction can be sprayed. Okay, how we check it out? We can see the cutting is more on the cervical area rather than on the occlusal areas. Okay, so we can appreciate according to that. Okay, so I'll just reset this. Okay, I've tried to make it as minimum. Now all the undercut area is on the wall. We all have to always see that my undercut area should not be there on the margin line. Reason behind this, if it's there on the margin line, then there will be a micro leakage. So maybe cement will not flow that area. So there will be a micro leakage. If is there on the wall, undercut is on the wall, yes, that area can be filled by the cement, but it should not be there on the margin lines, right? So after making the insertion direction, we set it and then we go on the next stage. So the next stage is it's a final margin line, right? It's on the final margin line. Okay. Now we can see the undercut area also, right? So how we can differentiate that, if it's an undercut margin line, margin is coming under the undercut or not. Right now, we all can appreciate that this line is green color, but if it's in the undercut area, then it will turn to red. Okay. This feature is available in all the software, right? What data this? How will you differentiate? Now this will tell me that only these points are coming to the undercut area. Then we have to recalculate, we have to redesign the margin line. As soon as we redesign it, we get it properly. So we have to make the final margin line. I'm considering the outer margin line. So I will just making accordingly. See, now it's on the undercut area.
Do you have to fill the undercut first and then design the crown?
Ma'am, it all depends on the actually dentist and the lab person, ma'am. If they want to fill the undercut, we can do it on the scalp itself. We can see it there, it's an undercut there. We can just build up there and we can design. Or we can trim it from the occlusal surface and we can design. Or if we want, the dentist can re-prepare and send it back to us. Or we can do the final is, if we have a model scanner and we want to scan it from the model, the lab person can do the wax up on the undercut area and they can make the scan. But if it's scanned by the intraoral, I would really suggest that the dentist can check it in their end and then they can send it to the lab.
Yeah, thank you, Ashutosh.
So after making the final margin line that we have, it's a green color, we'll go on the final stage, that will be a designing stage. Now the software will give me a basic values that how much the cement gap, how much the extra cement gap, how much the smooth surface, how much to be a real composition is there. Okay, the software will automatically ask me for the same thing. Now, according to the material, we have a different values. So we have a gold, we have wax, we have zirconia, we have titanium, we have prefab, zirconia, titanium, PMMA. All the materials are there which we'll be designing. So 3Shape has an option that you can design. The values are already pre-feeded, which is tested and tried. But yes, we can change these values also according to the case to case. So after filling this, the cement gap will be filled on. So I was just going to the final stage. This takes time to calculate this crown. Okay, the software has given me a general crown. which is bigger and it's not appropriate. So we need to.
So this is AI-based fabrication of crown by the software.
Right. So we need to design, but according to our preparations, right? So we can first, as I said, we can copy the scan. Okay, so software has, if we can appreciate this, software is automatically connected to the margin line. But to design the case, first of all, we need to disconnect from the margin line. So we have an option here. We can just disconnect from the margin. So it looks like this way. So if it's disconnected from the margin line, it gives me a solid model, solid ground. But if it's connected to the margin line, it will give me a hollow. Okay. So first thing is, if I want the same anatomy, which the adjacent tooth, I mean the other arch tooth is there, we have an option here called as a copy or a mirroring tooth. We just click on the mirroring tooth and we select as copy from the scan. So we click on the tooth which need to be replaced and we click on the tooth from where it should be replaced. So I double click this and I'll get the same anatomy tooth on the other side. And then we need to final edit the positions and copy. So I'll get the same anatomy now, which is there on the same other tooth. I don't have to change and select this line. I just need to, I click on the adjacent tools and I just do the positions.
So now once you have the mirrored contralateral tooth, now you have to modify it according to the lower
jaw.
Lower jaw.
We can just activate the lower jaw. We can check where are the contact points are coming. So we'll just try to adjust the points. So we'll rotate it from all the view. We'll look at, we'll try to fix it. We can increase and decrease the width also. So now we can see this is the very minimum. But what I tooth where I'm going to make. Okay, I can increase and decrease the width also. I can decrease and increase the width also from here. Now the second tool we have, that is the morph tool. I am not touching my anatomy. I am not touching anything. My tooth is on the same. I am just reducing from the contact points itself. So I'll guess a very less. Same we have used. I click it on the add and I can increase and add wherever I want. Then I have an option called as remove. I can remove a little bit. Okay. Then I have an but maybe it's treated or maybe there is a cervical abrasion. So we don't want that. We'll just trim the highest point.
Our maxillofacial defects implants using MIS software where we mirror the contralateral part. If I say that we can also design on our with our softwares which we use for maxillofacial.
Okay, but I guess there will be facing the margin lines and all, right? There you have the margin lines and all. And we get the same thing for the designing. Plus the contralateral designing is always there. We can customize our own designing as well. So for the dental part, ma'am, which is the most important thing is making the margin line and an accuracy. So accuracy, first of all, is very important. If I can't appreciate the margin line, I can't design it. Secondly, I can't draw the margin line. How will my crown knows that which is the point where he has to rest? So that is 2 points, I guess, which is very important for the designing of the crown. So we can just design according to our workflow. We can check for the contact points as well. So you can see it here, our contact points are there. Plus in the software also we something called a smart tool where we have already a pre-feeded value that how much the contact we want from the adjacent, then how from the occlusal surface and the inner surface. We just click it on the play button and it will automatically reduce the contact points. So we don't get a tight contact, we exactly get the edge to edge contact. Right? We can appreciate now here is a proper contour is not there. So there could be a food lodgement because of the even iterations are there. We can just design with the help of the morphologic tool and increase the count. So we can do the final editing. Now after designing the final crown, doing the final editing, we have to connect from the margin line. So we click on the margin line connection and we'll click on the play button. So after clicking on the play button, the software connects the tooth with the margin line. So we can see it here. Now it's properly connected to the margin line. It will be a hollow tooth. If I remove the scan, this will be a look like this. The milling will be done according to this way.
Dr. Ashutosh, there is a question.
Right, ma'am.
Are these libraries as per European or Indian measurements?
Ma'am, these libraries are according to the libraries of the tooth libraries which is available in the markets. So whether it's an iBookla tooth library, we have an Evita. So these are all depends on the US as well and the Indian as well. So it depends on us that which library we import. So we have a library which is available. Few of the libraries, yes, are the European, US-based libraries. US libraries are there. The truth libraries you're talking about, right, ma'am?
Yes.
Right. These are maximum are the US-based, ma'am. Maximum are the US-based.
Okay.
But since we are doing the milling, right? I just want to say, since we are doing the milling, so the library, I mean, the milling machine of ours will do exactly the same tooth milling, which we have imported the libraries. And right now we have just copied the other tooth. So it will be the same as the tooth which is there on the patient.
Yeah.
Okay. So after connecting to the margin line, we have put it on the final stage and the tooth is saying me that there is a very, we can appreciate this red mark. So the software is itself saying me this is the thinnest point of the crown. If we do the milling, there could be a chances of drilling holes on that point. So you need to do a patchwork. So he's asking whether he filled this or not. So we say, yes, you fill this. So this part will be filled and be ready with the crown. So this will be a basic workflow. As soon as we're ready with the crown, we have an option here to lift the indication.
Yeah. One more thing. If the model is scanned using a lab scanner, the color is lost.
Yes.
So what the labs want now? A picture using a mobile phone or like a shade card?
Or shade measurement?
For the color of the tooth.
For the shade measurement, right, ma'am? So, okay. So if we take it from the intraoral scan, the doctor can do it by the 3-shift scanner. It's a feature in the software that you can take the shade measurement directly by the scanner itself. So there we don't require this. But if there is a model scanner, yes, the dentist has to do the physical shade guide on the patient end. He has to do it. And whenever he is sending to a lab, he has to write it on the form that this shade he wants on the tooth. Then the lab person, because these are all designed on the white opaque milling machine, I mean the material, zirconia material. After milling only, the lab people will do the shading and coloring. So they will do according to the shade sent by the dentist. Whereas if they want, they can select it from here as well. They can just take the picture and do it. But that is not recommended. Third thing is, if the dentist has a lab scanner, but they don't have a designing software, then they'll be getting that this way. So the dentist will be making the, taking the shade guide physically, or they have a digital or they have a Vita shade guide handheld. So they will be taking from the directly on the patient mouth, and if they're sending the digital file to the lab, then they have to send on the email as well that which shade guide they want. I mean, which shade color they want. But if you're sending to a 3 shape to 3 shape, you get a direct color. So on the order form itself, you have a option to take it on the sheet.
Yeah.
So this is an order form. I mean, we designed the case and we can appreciate that how crowns are done. And as soon as we close the case is automatically stored in my C drive.
How much time does it take? How much time does it take to design one crown?
Okay, for me, ma'am, you can say a maximum. If we don't, we do it in workflow, it takes maximum 10 to 15 minutes to design a one crown. But yes, initially that takes time to understand the workflow because we need to learn from where which icon we have to select, from where what we are doing. Yes, but as soon as you learn perfectly, it takes maximum designing is 15 minutes to design a crown. And if you go on more pro, it takes 5 to 10 minutes maximum.
Supposing we have scanned our implant, dental implant, and we need to scan it now and design an abutment.
Okay.
So what software would you like to use for designing the abutment?
Okay, so ma'am, if you're talking about the customized abutment, there are the workflow is there for the scanning of the customized abutment as well. So which considered start from the intraoral scanning. So if somebody want a customized abutment, the person has to take 4 scan. First is the hex scan. The customer and the dentist has to scan the hex position of the intraorally. Then second, he or she need to scan from the scan body. Scan body is basically a PEEK material or a plastic material scan body. Every implant company has their own scan body, digital scan body. I would rather use this word. And you need to place it on the patient mouth. You have to screw it. Then you need to scan with the scan body. The third will be the antagonist arch, and fourth will be the bite of the tooth without the scan body. So the scan body is helping the lab technician or a dentist that which is an implant level and what is an angulation of the implant. Okay, that need to be sent to the lab. Now what lab will do is lab also have the digital file of the same scan body. Now they will overlap that. With the help of that, the lab people will design the customized abutment, and then on over that they will design the crown. Now it's on you whether you want a screw retained crown or you want the cement retained crown. That depends on the dentist. But we have to follow that workflow. Whereas if we scan it on the lab scanner, there is same workflow is there, but instead of having the intraoral scan body, there we need 2 things. One is the lab analog, and second will be the lab scan body. Lab analog is basically replica of the implant which you have placed on the patient mouth. That is called as the lab analog. So we have to place it on the model, or the dentist will make the scan with the what I use this word is castable scan body. Then we place a lab analog over that and we design. So there is a 2-way properly for scanning of the customized abutment in screw retained crown. But yes, on designing we can.
Yeah. Can you show us sometime the designing of the customized implant as well?
Check it out my case. Yeah, I think I have a case, but I'll show it sometime now.
Okay.
Ma'am, any questions, ma'am?
I can't see any on the chat box. But yes, if anybody wants to ask anything from Dr. Ashutosh, you are free to ask. Please go ahead and ask him.
Ma'am, I wanted to ask that, this is a customized software like Dr. Ashutosh for the crown, but there are softwares like Geomagic in which free-form drawing can be done. So can we design a crown in that?
Yes, we can design. Here the advantage is that everything is on the library, so you don't have to actually build around it. But yes, the one who is experienced in designing can
Use free.
form its own library.
Can design it in any way they can. They are not bonded to the software, I would rather
We
say.
are not bound to purchase those softwares for dental crowns and bridges or abutments. If we can do it on our maxillofacial softwares, we can do it
Anywhere.
anywhere.
Thank you.
Pradeep, do you want to say something? Our clinical engineer who designs the maxillofacial devices for us.
No, ma'am.
Okay.
So I guess, ma'am, we don't have any questions.
I don't think we have any questions, but we would love to see if you can show us abutment designing.
Ma'am, I don't have a case today, ma'am, for the abutment designing.
Okay. Can we share you we scanned maybe day before yesterday with scan bodies. We scanned with our intraoral camera.
But ma'am, I need to have checked it the which scan body you have used. I need to have the digital libraries as well. For
Okay,
that.
so it's good if you show us your file only and just a demo of how you are doing the.
I'll check, ma'am.
Maybe
I just
next
checked.
time when you are with us, you may show.
I'll do that, ma'am. What I'll do is I have a demo case. What
Yep.
I'll do is I'll import the demo case and I'll show you that how we design a customized abutment or a screw treatment crown. I'll
Yes.
definitely do it.
Yes. So with this, I think we can end today's session. And tomorrow we'll have Dr. Richa Khanna. And then again, day after, Dr. Ashutosh, you are back with us?
I think yes, ma'am. And there I will be changing
After
the
we'll
exporting.
be looking at this, at that demo.
I'll do that, ma'am. What I'll do is initially I'll show you how to export the file from my intraoral scanners.
Yes.
And then I'll show you that how we import the on the software and a basic workflow for the implant design. I mean the customize the button.
Thank you. I think Dr. Sumit wants to show the lab scanner. He has video.
भैया फिर आएगा मैं अभी
Sumit, you will have to unmute yourself.
Am I audible?
Yes.
As the topic of the day is lab scanner, so this is the setup. This is a lab scanner, and it requires a scanner and a computer system along with the keyboard and mouse. And mouse. So it is scanner is connected. This is how the scanning process.
While it's scanning, we can't see the screen. So how it's coming on the screen?
That I am having the slide is after the when you can appreciate the how the cast moves inside the scanner. Video shows the movement of the cast in various orientation in the scanner, and then the screen where it is captured will be it will be following this.
Okay.
The cast is fixed using this screw on the platform on the stage, and it is moved in various orientations. Another scanner. This is the Medit scanner, where the impression, where the cast is moved in various orientation and the details are captured by the software.
Yes.
This is how the screen shows when the scanner, on the scanner, the cast is being moved and the screen shows these options. First, there is a scan option. When we click on it, the scanner is connected. This is the scanner, UP3D. First, the occlusion, both the casts are placed in occlusion and then it is recorded. The occlusal scanning is performed. This is followed by the upper jaw scanning. The maxillary cast is scanned. We can see the surface details on the cast. We can move it in various orientations. This is the area of interest, as we have to fabricate a crown on the tooth number 6.
Okay.
This is followed by the lower cast scanning. Followed by the occlusal alignment, and the data is imported into the designing software. The designing part was shown by Dr. Ashutosh, and we will be further discussing it in the coming week.
Okay.
This is the workflow of a lab scanner.
Thank you. Thank you. So now with this, we can end today's session. Thank you all.